Hello everyone, welcome to my channel. Today, I had the pleasure of assisting a customer with the refinement of 3 intriguing blubs in order to determine the amount of gold and silver they hold. Among these blubs was one weighing 290 grams, characterized by its round shape, and unique gold and black coloration, giving it a visually appealing and heavy appearance. To begin the assessment of the gold and silver content within this particular blub, I extracted a 100-gram sample and initiated the refining process by introducing 100 milliliters of water and 100 milliliters of nitric acid. I give it heat at 80 degrees Celsius for 40 minutes. By adding nitric acid to the solution, it start to releasing deadly nitrogen dioxide brown to red in color. This video is speeding up. I will boil the solution until no gas is being released. It's time to filter the solution and repeat the process again by adding 100 milliliters of water and 100 milliliters of nitric acid. And boil it again for 40 minutes. It's time to filter the solution one more time. I repeat the process again by adding 100 milliliters of water and 100 milliliters of nitric acid. And boil it again for 40 minutes. I will repeat this process 4 to 6 times until all impurities dissolve in nitric acid, leaving only gold behind. It's time to filter the solution one more time. I repeat the process again by adding 100 milliliters of water and 100 milliliters of nitric acid. And boil it again for 40 minutes. It's been 4 times I boil this material in nitric acid. As you see, there is less gas and less reaction. After 40 minutes it's time to filter the solution for the last time. At end of this step what is left is a dark material. To start the second step I add mix of 200 ml of hydrochloric acid and 30 ml of nitric acid. And let it boil for 30 minutes. By the time aqua regia start to dissolve gold and other precious metals and color will change from black to yellow. It's time to test the solution with stannous chloride to determine if gold is present. Depending on the precious metals present in the solution, the reaction of gold with stannous chloride may turn black. I add a cube of ice to cool down the solution. Let's filter the solution. I will use cotton to filter it. If the solution is cloudy, indicating the presence of silver chloride, I may need to repeat the filtration process twice to achieve a clear solution. Solution is clear enough to precipitate gold. At the end of the second step, we have two solutions. One, which may exhibit a blue to green color on the left side, contains silver and copper. If the copper concentration is high, the color will change to green. The other solution on the right side may appear yellowish to red, indicating the presence of gold, platinum, and palladium. I will proceed with isolating the gold. There are various methods to precipitate gold from a solution, including utilizing substances such as ammonium chloride, sodium metabisulfite, and zinc. By adding some ice cubes, I am attempting to cool down the solution and prevent a sudden reaction. I will use sodium metabisulfite to precipitate gold out of this solution. The mixture of aqua regia and sodium metabisulfite produces a hell of the smell and generates heat. By adding sodium metabisulfite, gold starts to precipitate. The solution's color will change from yellowish to colorless and then to dark. Adding approximately 6 scoops of sodium metabisulfite will precipitate all of the gold present in the solution. It's time to test the solution with stannous chloride to ensure that there is no gold remaining in the solution. The result is negative, indicating that there is no gold in the solution, therefore, there is no need to add sodium metabisulfite. I heated the solution to 60 degrees Celsius for 10 minutes. Over time, gold powder precipitated at the bottom of the beaker, leaving behind a clear solution. Let's test the solution one more time. Surely, the result will be negative. It's time to wash the gold. I will do this by rinsing it with boiling water several times. Then, I boil the gold powder in hydrochloric acid for 15 minutes to dissolve all the impurities left in the gold powder. By boiling the gold powder in hydrochloric acid, the dark color of the powder will change to dark brown or light brown. It's time to wash the gold powder with hot water for several times to wash away the acid. Up to this point, this powder does not resemble what everyone recognizes as gold. However, once melted, what remains will become familiar to everyone. Last but not least, transfer the powder to a melting dish. Add some boric acid, and start with a low flame until the powder begins to fuse together and mix with the boric acid. Then, gradually increase the flame to melt everything together. You must be aware that as the carat and weight of the gold increase, it will require higher temperatures to melt. I add hydrochloric acid to a small beaker and boil the gold nugget in it for 10 minutes. It's time to wash the gold nugget and then weigh what I've been working on. It has been almost 6 hours since I started the process. The nugget looks perfect in weight and color. The nugget weighs 11.82 grams and is composed of 97.5% pure gold, which can also be expressed as 23.4 carats out of 24 carats of gold. Now I can inform my customer that there is 11.8 grams of 23 carat gold present in 100 grams of the bulb. Thank you for watching my video. Remember to hit the button below if you enjoyed.